Okay. So we're going to try to understand what a class really is. Okay? At least in more depth than what I described in the previous. So I had to give you some information to get you started in your assignment, but now I want to make you think a little bit more. Okay? And by understanding this concept, we'll be able to write multi-class programs. Okay? I gave you examples of multi-class programs, and I want to just talk about that subject in a bit more depth so that in your next assignment you can write multi-class programs. Okay? So next assignment is essentially going to be a multi-class program. So that's the new programming construct you'll learn, and you'll be scanning not just integers but also words. Okay, and maybe even quotes. Okay, I'll see. So I'm going to use an analogy. And here we have somebody following a script. Okay, she's looking at a song words and singing. And can you see how that might correspond to programming? What would be a script in the programming world? Yeah?
Well, I was going to say it correlates to programming because he's giving input in the form of notes.
Input, but that's the user, end user. Think of the programmer. So, yeah. This code will be the script, and who's executing that? The CPU, ultimately, right? Okay. So it's a good analogy. When I teach Comp 110, that's how I begin my class. Okay, we talk of the theater world, we talk of the computer world, and we make an analogy. Okay. Now in scripts, you have sentences, and sentences can be grouped into paragraphs, and paragraphs can be, supposing you're writing a play, you're writing a Shakespearean play. What other entities might there be? Scenes. Oh, good. I'm using the words you're using. Okay. And then, right? Can you see? And that's the Shakespearean play. But if you're doing treating, who cares about the structure? You've got a certain number of characters, you write this, sentence. Okay. Can you sort of see a programming analogy here? So what would be sentences, scenes, acts? What would correspond, given these pictures here? Yeah.
The thing on the left, it would be like your one Python program, and the tweet would be like Hello World.
So the tweet would be just some program that you wrote as Hello World, and the Shakespearean play would be a Monty Python program, right? So we have languages that are designed for Shakespearean plays, and there are languages that are designed for tweets. Okay? And the languages that are designed for, and Java is an example that's designed for, is a language designed for plays. And some language that that's good for quick and dirty programs. Assembly, is it quick? It's dirty for sure. Some language that you might use that might start with the word Java, maybe, okay. Or Perl, there are all these languages that are meant for quick programs where you don't get into these big, these organizational things. So, people love Java, people hate Java. The guys who want to write tweets don't like Java, okay. And there's a lot of people who write tweets, many more than who write Shakespearean plays, okay. But again, this is a computer science course. We are trying to teach you how to do program well. And I don't think something as complex as Eclipse could have been written with the reliability it has if it was not written in Java. Okay? A lot of other things could be written in, Python is somewhere in between. But if you really want to write something so complex and that involves so many people, you need this language. Okay? And so let's go to the details. So a script or a folder corresponds to what in Java from what you learned in the previous class? Package, very good. And an act would correspond to a class. It's stored in a file. A scene could be a method, declaration, statement, who knows what. Okay. So you have local declaration statements, global declarations, and your methods have local declarations, the parameters and other variables, and statements. And the global declarations would be what declarations? What is global about them? Sorry? So the multiple methods in a particular class may want to share something. That's your global. And so then the unifying concept there is a class. Okay? And then you have packages. Okay? And, you know, with Perl, you can just write quick programs. And, you know, like I said, you know, even when I have to write small programs, I use Java just because I feel more comfortable and just because I'm very error prone. But a lot of people say, why did you write a Java program? You could have used Perl, you could have used that. And that's true. Okay? So it's not as if there's only one language to use in your life. Okay, so here's a piece of code. And this is not something that you can put in as a standalone Java program. Okay? And what is this piece of code doing? Anybody? Yeah. Okay, so n is the number whose factorial is returned in the variable product. Excellent. Okay? And, you know, you figured this out by just looking at this code. I'm very impressed. But if I had put this code there, it would have been much easier. So you can see why methods are good. I mean, you're naming things. And, you know, and people say, I often ask people, so what name is this variable should be? And they say, what's in a name? Okay? Talking about Shakespeare. And I say, yeah, because you'll have to figure out what it really does. Okay, and and I'm calling it looping factorial. I really like long words, right? I could have called it factorial. So looping factorial, I'm calling it to contrast it with, which would be something you guys might have learned. Recursion. Okay, so anyway. And this you have to put in, I put that in a class called factorials, and then that is in my package. Okay? So this is a standalone piece of code that you can compile in Java. You couldn't compile that other piece of code. Okay? Questions? Okay. So what does this word static mean here? I saw some Piazza discussion on this. And why did I say static? What significance does the word static have? And I won't go into as much depth as one can, but I want to go in so much depth that you know how to use this word in basic ways. Yeah.
I know that a static method can be called just by referencing the class name rather than an object from the class.
Okay, so static means basically we're not doing object-oriented programming. Okay, this is the classic programming, procedural programming, and we can call this method on the class factorials. That's what the static means. And the class factorials was created statically. It was when you wrote the program, it was there. It's not as if it got created when the program was running. Okay, so. So that's what it means here, and you'll see it here. I can create a permutations method in another class, okay? And I go and define that. I hope I've done this right, by the way. It's been it's been a while since I used permutations directly. But I'm calling a factorial twice, and I'm saying looping factorial is being called on this class factorials, which exists at compile time, statically. So another word for static method is a class method. It's a method you call on a class. Classes are static, so the method also becomes static. Okay? And so this is the class on which you're calling it. Okay? Yeah.
In computer science 110, you guys have the form object class method. Is that like the same thing as class method?
So objects is something we haven't seen in 401 so far. So it's new speak, right? It's not what we'll see that later. Imagine there's no objects. If there's no objects, you only have classes. You can call methods on classes. Classes are static. So methods that are called on classes must be declared static. So just think of them as boring methods. Boring is static, and right now we're doing boring programming, so we have to say so. Okay? Yeah. Oh, sorry. Thank you. This should be capital F. Okay? Yeah.
I'm curious, what's the opposite of static?
Not boring. So opposite static is nothing. So by default, if you don't put static, it's dynamic. Okay? So because, you know, so this is like saying we'll punish you for doing boring programming by using the word static. Okay? So if you don't want to type so much, don't put static. Okay? But right now we know nothing better. We don't know better, so we're going to use that. Okay? And we're going to gradually, I'm going to show you historically how objects evolved also. Okay? But you guys, everything fine? Okay, I have to correct that a typo. Now I'm going to create another class. Okay, so factorials is an expensive computation. Okay, so once I get the factorial for a number I'm interested in, I want to store it somewhere. Okay, so what is this class doing? It's a class with variables, global variables, and methods. And I'm calling it a factorial spreadsheet. Maybe that's confusing you a little bit. Why is it a spreadsheet? But what's it do? What am I doing here? I have the method. Let's look at the methods. I have a method called getNumber that returns what? Whatever is in this particular global variable number. Okay? I have a variable, something called setNumber. What does it do? It sets a number, plus sneakily it has also something else it does. It goes and assigns to this variable factorial the factorial of the number, and I'm going to just use the looping factorial from factorials. Okay? Now if I go into get factorial, I'll get the factorial of which number? The number I last set. Right? So if I set the number to 4, I'll get the factorial of that number. Okay? Okay? Yeah.
Is there any reason to leave the two variables package protected instead of private? Or is that just...
So I don't even know what private is, but it's not public at least.
Okay.
Okay? We'll get into that much later. When we go look into inheritance, that's when all this stuff will make sense. Okay? So you guys get what's going on here? I have two variables, 3 methods. One method returns the number, another method sets a number, and it also computes the factorial. So the public here means that actually this should be wrong. The public here means that it can be accessed from classes, other classes, in whatever, the same or different packages. I have to correct that. Okay, the public means it's exported outside the class boundary. Okay, which, yeah.
So you're using this as a public face for your other factorial program. Say someone else wants to use your program to create factorials. This is the interface they will use.
You can say that. We will see that there's something called interfaces in Java, and if your methods are static, you can't put them in interfaces, which I think is a really bad design in Java. Okay, but Java says you should be using static anyway. So 2 wrongs make 1 right. Okay, we won't let you use, if you're using static, then you don't put them in interfaces either. Okay, but that is the right way to think about things. Okay, and I did not put public here. I put static here. I could have put public at number, but I didn't do it. Okay, there's something called private also. We don't know what that means right now, but we know what public is and not saying public is. Okay, so it cannot be accessed from, again, I shouldn't say classes and other packages, from other classes, period. Whether they're the same package or different package.
Is the default package protected? Default view?
Yeah, so that has to do with classes. So the default is arbitrary classes is the right word. Okay, so I guess I am right here that it's not accessible from arbitrary classes in other packages. That's what I should be really saying here. Cannot be accessed from arbitrary classes in other packages, and sometimes you can access them, provided that's a default. So I don't want to get into that right now. Okay, but that's right. I'll rephrase this, that the correct thing to put here is that cannot be accessed from arbitrary classes in arbitrary packages. That's what public. Okay, so right now we just know public and non-public. Okay. Now, why did I make? So I'm calling it this spreadsheet because, you know, like it's like a grade spreadsheet. You give in the grades and you you give in the scores, you get the grade back. You put in the number, you get the factorial back. We've got this formula that's computed for us, and only when you change the number will the factorial change. Otherwise, the factorial won't be recomputed. So it's my factorial spreadsheet. Okay? Okay. Sorry. Principle of what should be visible outside. I lost the recording. Anybody can give the name for that principle? Black box. Yeah, okay. Abstraction, that's good because I'm hiding things. Encapsulation, something that you might learn in ordinary language, maybe in the military or... Excellent. Need to know. Where did you learn this?
Watching TV.
It's also called the least privileged thing. You know, it's like, don't give somebody more rights than they need. Otherwise, they may leak the stuff. Okay? So, it's called the least privileged principle. Do not, and that principle says, and that principle translates into not making non-final variables. Variables can be final, which means they're not really variables, they're constants. Those can be made public. But anything that's not a constant, just don't make it public. And this basically says, do not give user of some code more rights than it needs. Don't tell it how you're going to do things, because you may change your mind later. Or who knows, you may go and do bad things to it. And in this example, if I had made my number and factorial variables public, what bad thing could have happened? You could just put arbitrary values in it. For arbitrary numbers, you could put arbitrary factorials in it. You written this code to compute the right value, but the user is able to go and change it, and you know, it's like your warranty goes away when you open your mobile, when you fix your mobile phone yourself or your car yourself. So your warranty goes away essentially if the public variables are used. Yeah. So you could change the number without changing the factorial. That's basically that. You could go and put arbitrary values in it. Okay, so now you sort of see the reason why you'd want to protect these variables, and not putting public means putting some kind of protection. Public means there's no protection. Okay. So another way to state this is that export state through properties, and we'll see what that means next time. Or did you have a quick question? So if I did not declare these variables as static, my static methods couldn't access them. So we are doing, like I said, boring programming, which means we have to put static every time we declare a variable, and static every time we declare a method. Okay? Okay. It's also called the least privileged thing. You know, it's like, don't give somebody more rights than they need. Otherwise, they may leak the stuff. Okay? So it's called the least privileged principle. Do not, and that principle says, and that principle translates into not making non-final variables. Variables can be final, which means they're not really variables, they're constants. Those can be made public. But anything that's not a constant, just don't make it public. And this basically says, do not give user of some code more rights than it needs. Don't tell it how you're going to do things, because you may change your mind later. Or who knows, you may go and do bad things to it. And in this example, if I had made my number and factorial variables public, what bad thing could have happened? You could just put arbitrary values in it. For arbitrary numbers, you could put arbitrary factorials in it. You written this code to compute the right value, but the user is able to go and change it, and you know, it's like your warranty goes away when you open your mobile, when you fix your mobile phone yourself or your car yourself. So your warranty goes away essentially if the public variables are used. Yeah. So you could change the number without changing the factorial. That's basically that. You could go and put arbitrary values in it. Okay, so now you sort of see the reason why you'd want to protect these variables, and not putting public means putting some kind of protection. Public means there's no protection. Okay. So another way to state this is that export state through properties, and we'll see what that means next time. Or did you have a quick question? So if I did not declare these variables as static, my static methods couldn't access them. So we are doing, like I said, boring programming, which means we have to put static every time we declare a variable and static every time we declare a method. Okay? Okay.